Hello, my name is Shakid, and I'm a security researcher at ARGUS Cybersecurity, and in this video, we'll be talking about penetration testing and its importance in automotive. Let's first consider the risks for us as manufacturers of cars. Well, let's assume that a public article is being published on the internet describing how our mileage of our cars can be modified. This could be very serious for us as a brand because it hurts our reputation as a reliable brand. For example, our cars may be modified easily. They may not be trusted that much as we would like our customers to think. Hacking our cars does not only implicate that, it also means that the privacy of our customers may be compromised to hackers if we are hacked. But most importantly, the risk of having our car hacked and having our brand damaged by these security vulnerabilities is, let's not forget, this is physical damage that could be inflicted on our customers. Once something like this, which is that serious, is publicly available, fixing it is not always easy. It is not always trivial to find it and to find its solution, but more importantly, it's really difficult to roll out an update to a car that doesn't have an update mechanism already implemented inside of the vehicle. For example, over-the-air update. This would result in a recall to our customers, which would force them to go to the nearest shop, and they will have to update the software manually. This is something that is also bad for the customers and their experience from our brand, but also very, very expensive for us as a manufacturer. So in order to do something about that, there is this concept of performing penetration testing on your components as part of the regular development cycle. Penetration testing is the process of having your system audited by an experienced hacker, which would simulate the way that a regular attacker would think and do to your system, while doing so in a controlled environment and having it monitored and learning from this process. The typical tools an attacker would use for these kind of tools, for this kind of job, is first of all having to get access to the code. Sometimes access to the code is not publicly available and it has to be extracted physically from the PCB, from the ECU itself, and it would have to be reverse engineered. Reverse engineering can be on these binaries is usually done using the IDA Pro suite, but also the recently available Ghidra. And also an attacker has to be familiar with these special kind of microarchitectures that are around on automotive. For example, the Infineon Tricore or the Renesas RH850. And these just an example of such. Finally, an attacker would sometimes want to test its exploit and its payload once it had found a vulnerability that it tried to exploit. To do so, it would use a JTAG debugger, for example, jailing for ARM targets, and craft its exploit from there. So to look at an example of such vulnerabilities that could be discovered on an ECU can be looked at from this example of a use case that we had at ARGUS a few months ago. Specifically, this is an instrument cluster ECU, which is composed of two main microcontrollers. One of them is in charge of the graphics because this is an instrument cluster, and the other one is attached to the CAN, and it is handling the CAN messages as they are received, and they communicate with each other. What we found in this vulnerability was a very powerful write everywhere primitive, which is exploitable using only a CAN message. So the first thing that an attacker would be able to do, and this is the easiest thing, would be to leak some important secret from the microcontroller itself in case of an absence HSM, in case of the secret not stored in some external microcontroller or secured or other secured storage. If the secret is stored directly just on the microcontroller, attacker that is able to control the microcontroller is able to leak that secret. And again, since this is the nature of this vulnerability, this could be happen only with access to the CAN. The attacker does not need some invasive method in order to extract that secret. But that is not the only thing that the attacker can do, because if an attacker is able to detect that vulnerability and he's able to exploit that, he's able to get complete remote code execution on that microcontroller without having to interact physically with it. All it has to do is to send a very carefully crafted CAN message, and the microcontroller is his. And this is what we at ARGUS have performed once we have discovered this vulnerability and realized its potential. And since this is an instrument cluster, we decided to show a visual effect. So over here we can see the microcontroller, the ECU itself, and there's a LED strip right here that is attached to it, which is part of the visualization of the instrument cluster. And after getting control, after sending a message, a very carefully crafted CAN message, we are able to take control over the device, and we are able to do whatever we want with that LED strip. So after sending the message, we were able to blink the LEDs as we wanted, and this is demonstrating the fact that we are in complete control over this ECU. If the screen is attached, we're able to demonstrate and show different autometers values or different speeds or any other thing that the attacker would be interested in doing. Eventually, the outcome of these penetration tests is having early detection of these critical vulnerabilities and bugs, because now not only we are able to fix them early and save us a lot of work and, of course, complicated process of updating our software remotely, but even if we don't find all of the security features and all the security vulnerabilities in the system, the fact that the developer already reads some of the comments and is able to reflect that on its own code, he's able to increase his security awareness and that would help him develop future code to be more secure. And finally, the vendor will have this, we will have this assurance that we know that the system has already been through the eyes of an attacker. So the next attacker out there in the field that would try to hack our system will probably have to work much harder to gain these, to exploit these vulnerabilities on his side. Thank you very much.